Recording. Welcome. Hope you had a nice weekend. I did not get as much done as I was hoping to. I did start marking the test. I did adjust assignment 3, of course, so that's done. But I haven't finished marking test 1, so I'll finish that today, hopefully. But I like to be thorough, so it takes me some time. But let's get started here. Okay, so we started chapter 4 last day. Last day we introduced things like exponents and logarithms. So just in terms of review, we talked about exponents, right, and exponent laws. Right. How do we simplify exponents depending on their base, right? That'll help us simplify exponents if they have the same base, for example, right? And there were a couple of rules that we have to have up our sleeves. Same thing with logarithms, right? Log laws. Oops. Specifically when we have to solve for, so when do we use logarithms? When we need to solve for x, when it's in the exponent. Oops. Oh no, my pen's doing something weird. Last time that happened, I had to buy a new Apple Pencil. Not good. For x, when it is in the exponent. Okay, so for example, right, if we have 4 to the power of x equals 30, right, and we need to solve for x, the only way that we have to get that x down and accessible to us is by taking the log. Okay, and we talked about, we take the natural logarithm in business and in most applications, and there are some special cases, but usually we talk about log base e, the natural logarithm. And because it is the most common log, we just call it the log. So we have 4 to the power of x is 30, but when I take the log of both sides, okay, and I write it kind of cursive here, so the log, the natural log of 4 to the power of x is the natural log of 30, right? You have to do it to both sides. Now, taking the log of something just generates a number. So the log of 30 is just a number, but we'll keep it as the log of 30 to keep it exact. But the main log law that we use says that, okay, well, if I take the log of something with a power, that's equivalent to moving the power up front like this. X times the log of 4 is the log of 30. Now I'm able to solve for x and say that x is the log of 30 divided by the log of 4, which would generate a number, but I'm just going to keep it like that. Okay. And so that's how we use logarithms, and that's why we needed to introduce them. They're not tested explicitly, right? But you do need to be comfortable working with exponents and working with logs. And I posted on our Moodle page, I posted the chapter 4 practice questions in case you don't have the textbook, okay, with the solutions. And I think I even said something like it's not tested, or oh, we don't need that. That's for stats. Oh no, it's so slow. I didn't want this. I wanted Moodle. I haven't done my password yet, but I will. Or maybe I did already. Can't remember. Okay, so I did post, let's see here, the chapter 4 problems and solutions, and it's slow. I'm just going to check what, okay, this one's on the right Wi-Fi. How do I check which Wi-Fi this is on? Okay, so here, it even says section 4.1 is not tested, right? But you do need to have that knowledge. So just work through those problems and just make sure that you have it all under control, right? And then we'll start section 4.2 today and kind of work our way through chapter 4 this week. Oh yeah, I want to just check. Okay, it's on the right Wi-Fi, so I don't know why it's so slow. It's supposed to be fast. Demanding, I know. So that's it for review. Okay, so as I said last day, once we finish test 1 and we kind of introduced exponents and logs, now we get to start talking about interest problems, right? So money problems, how does interest work, right? If I make a deposit and then I am earning interest on it, how do I calculate how much I have at the end, right? And so that's what we're going to start today. And after that, we'll just keep building on these same concepts. Okay, so it's really important that you understand what happens today and from here on out, right? Everything else you can kind of fill in as you go, but these concepts are going to be really important. Okay, so 4.2 is on simple interest. We start with simple interest because it's not as complicated to talk about. It's not too complicated to think about. However, it's relatively rare in life that we come across simple interest problems. Okay, so usually, and this doesn't look like interest, so let me. So although simple interest rarely occurs, I want to say IRL, in real life, but I'll change that. So although simple interest rarely occurs in, well, I guess I'll say in real life, but I won't say IRL. So although simple interest rarely occurs in real life, we use it to introduce these concepts, right, in kind of the most basic sense. To introduce concepts of interest. So, and I mean money interest, okay? So concepts of interest in the most basic sense. So I think in general, just from life, we understand that, and especially if you're in the business program, then you probably understand that if you have a chunk of money, so let's say you have $1,000 and you take it to the bank, they will offer you some interest, which means that they will pay you to essentially borrow your money, right? And then in the end, you'll have slightly more than what you started with, right? So they'll pay you some percentage of that $1,000. And so that's what we're going to try to figure out is the time value of money. Okay? So in general, right, an initial deposit, okay, so here we're going to talk about, you might be investing money or you might be borrowing money. The exchange doesn't really matter, right? We talk about, okay, well, if I borrow money, then I need to pay interest. If I invest money, then they need to pay me interest, right? But the amount of interest is going to be the same. So in general, right, an initial amount of money right, which can be an investment or a loan, right? And that just determines which direction the money is going to, but the amount will be the same. Okay, so an initial amount of money called the principal or the present value, right? I'm going to try to call it the present value just to be more consistent with later sections, but usually we just call it the principal. So an initial amount of money called the principal or present value which we denote by P. Okay. That present value or the principal investment or loan, right, earns interest at some rate. So earns an amount of interest. And when we talk about the amount, we're going to use capital I. Okay. So it earns an amount of interest at some specified, rate of interest. And I'll use green for that. And we use a lowercase r. Okay. Okay. In general, an initial amount of money called the principal or present value earns an amount of interest at some specified rate of interest over a period of time. Over a period of time, which we'll denote by, oh, I already used, running out of colors here. The final value, right? So the total amount owing, right, from the bank or from you, depending on which direction this exchange went, right? Doesn't matter. The final value of the amount is called the future value. And the future value, I'll use maybe purple. We denote by FV. Okay. And maybe what I'll do here is P or PV. Now I only use P because it matches what's on the formula sheet. And for some reason, and I'm not sure why, I just was given a formula sheet and I don't want to mess with it. We use PV later on, but for P for simple interest, I think it might be an oversight. Okay, so first of all, to calculate the amount of interest that you've earned, okay, is let me bring in the formula sheet. That might be a good idea at this point here. Hey, where is it? There. So for chapter 4, these are the formulas. Now we've seen a lot of these components, okay? But I'm going to focus on these top two, right? Capital I and the future value formula. Okay? And then we'll introduce, so what if we have a changing interest rate? That can happen, okay? But let's see here. Let's see. To change something on my screen. Okay, so we'll deal with this changing interest rate formula later, but I think if you have a look, it looks very similar to this top one. It's just that here we have multiple rates, right? But we'll parking lot that and come back to it. So first thing we have is a formula to calculate the amount of interest. Okay. So I, remember, is the amount of interest, right? So same thing when we were talking about merchandising, right? The amount of the markup is not the same as the rate of the markup, for example, right? The ROMU. And then the amount of the markdown is not the same as the ROMDA, the rate of the markdown, right? They're different. And so I is the amount, and let me try to match these colors here. So I is the amount of interest, which means it's a dollar amount. Yeah. P is the principal amount. Right, which is also a dollar amount. Right, so that's the initial investment or the loan amount, doesn't matter. Let's see what color I used for R, green. R is the rate of simple interest per year. Okay. You have to use the proportion, right? So you can't use the percentage. Usually we communicate in percentages, right? It's 4% per year, for example, right? But you have to work with the decimal version, okay? And so need decimal for calculations. Okay, and it's important that it's per year, right? Sometimes we say 2% per month or something like that. Okay, and so so we have to clarify that it's per year. And T blue. Now time has to be in years. Okay. So time in years must be in years. Okay. Now for the years, right, there are a couple of things that we need to keep track of. Okay. And this is where I get a lot of questions. Okay. So here, note, time must be in years. In this course, we're going to assume that there are 365 days in a year. There's 52 weeks in a year. There's 12 months in a year. Okay, so, and those are pretty basic assumptions, right? I know it's not always true. We have leap years and stuff like that, but in general, right, these are the assumptions that we're going to make. So sometimes the question will say, okay, you borrowed money for 2 months. Now, how much do you owe at the end of that, right? And so that has to be converted to years. And so although it's quite obvious once you get going, right, I just want to establish these assumptions. So time must be in years. We will assume the following. Let's see here. Wait. Kind of inverted. So I'm going to try to keep it on the same page. And this is linked to T there, okay, in case that wasn't clear. So we're going to assume that 1 year has what's the 4 quarters? 4 quarters, okay, 3 months each, right? I'm just trying to think of the largest split that I could do of a year. 1 year has 12 months. 1 year has 52 weeks. And 1 year has 365 days. Okay. So when you talk about, okay, you borrowed money for 12 days, right? You need to convert that into years, right? Because time has to be in years. So then 12 out of 365 days. So for example, I have the dog this week and she's good most of the time, but she still chews on things. So for example, if you borrow money for or 12 days, what would the time be? What would T be? Right? T would be 12 out of 365 years. Right? It's going to be a small portion of a year, right? Because 12 days is a small portion of a year, right? But you have to use that same unit, right? Days to days. So we'll see some practice, of course, but I just wanted to introduce those assumptions. Okay. All right. So the next formula that we want to talk about here is, or that I want to introduce, or maybe let's do an example with this interest amount calculation first. How about that? So I posted these examples and I'll start with example 132. Oh, put it back in. Okay. Okay. If $5,000 interest is earned in 1 year at an interest rate of 7.3%, what amount was initially invested? Okay. And so let's outline the components that we have, and I'm going to try to use the same colors, although it's going to get tricky. So the $5,000 is the amount of interest. Okay, so although that's going to be a little bit tricky in the beginning, right, it's a good idea to just start picking up on that now. So I is 5,000. And that amount is earned in 1 year. Okay. So T is 1, right? Just remember that T is in years. And of course, this is our first example, so it's going to be very, very simple. Okay. And the interest rate is 7.3%. Okay. So I have the rate was 0.073. And when it doesn't say, we can assume that it's per year. Okay. What amount was initially invested? Okay. And so here we want to find P. Or maybe I'll just say P, or clean that up like that. Yeah. We only have one formula so far, and it's going to be the easiest one to use, although you could use the next formula that we introduce for pretty much every problem that we're about to face, but this one's a little bit easier for these little questions. Okay, so I'm going to use I equals PRT, right? And especially when you're reading all these other questions and we've introduced other formulas, right? The reason I chose this formula is because it's the one that's the closest match to the information that I've been given, right? So I have I have R, I have T, and I want to find P, right? I want to find a formula that has the majority of those. Okay. So now if I just plug in values, right, the amount of interest was 5,000. I'm going to try to solve for P. The rate is 0.073 and the time is 1. Multiplying by 1 just kind of dissolves, right? It doesn't do anything. So what I'm going to be left with is that P is 5,000 divided by 0.073. So 5,000, let's see here. Looks like I have it. So I'm just going to jot it down here. 68,493.15068. You know what? I'm not going to put the $ on yet. It's not money until I round it to 2 decimal places, right? And so P is, I mean, it is, but just be careful, 493. So 68,493 and 15 pennies. Okay. So you can manipulate this formula, right? I equals PRT. You can pre-manipulate it if you want to. You can take each of these and solve for P. You can solve for R. You can solve for T, although they end up being kind of similar, right? And so I don't think you need to do that. But if you do want to have them jotted out, right, that's totally fine. Your tests are all open books, so that's fine, right? So what could we have done here instead, right? Or if you solve for P first, right, just using these variables, then you can just plug in values right away. And you'll see there's not a huge difference here. It is going to be I divided by R times T, right? Which is what we did. Yeah. Okay. Nice. So what's another way of summarizing this result? Well, if I invested $68,493.15, at 7.3% for a year, right, then I would get 5,000 in interest, right, at the end of that year. Pretty awesome. You're not going to be able to find 7.3% anywhere. I'd probably not. If you do, let me know. But that's what we're calculating, right? If you flip it. Okay. Okay. So we're just going to use this formula to solve for the different components here. So we can solve for I, we can solve for P, we can solve for R, we can solve for T, right? And so here's another example. Hey, bad girl. Example 137. Hey. Jim's calculations, whoa, I don't want that. Jim's calculations show that the total interest owed to Jill on his $2,700 loan is $315.90. If he paid simple interest at the rate of 0.9% per month, now here, be careful, right? Because our rate has to be per year. So what are we going to do? We're going to have to multiply this by 12, right? Because there are 12 months in a year. And then we can solve for how long did Jim borrow the money, right? So we want to solve for time. So here, the information that we're given is, okay, so the loan amount, the principal amount of the loan was $2,700. Okay. The amount of interest is $315.90. And I think it was green. Yeah. Here, R is 0.009 per month, right? So then it has to be times 12, and that's going to be really important. And we want to solve for how long. Okay. Hey. So again, I have P, I have I have R, I have T. And so now I can use these to solve for T. And I have that one formula that has all these components. So that's going to be the most obvious choice, where I equals PRT. Okay. So I'm going to plug in my components here. 315.90 is 2,700 times R, which is 0.009 times 12 times T. Now 0.009 times 12, we simplify that first, is going to be 0.108 times T. No. So now, T, because I'm multiplying all the way across, right, I can just divide both of those components over to the left-hand side. And so now I have T is 315.90 divided by 27,000 times 0.108. So T is going to be 1.0833 repeating years. Okay. And usually we can just keep it in years, right? I don't want to convert it to days or anything like that, because what would I have to do? I'd have to multiply 0.0833 repeating times 365 if I wanted it in days. I don't care about that, right? 1.083 is fine. Okay. Or how could I solve for this? If I just solve for t immediately, t is I divided by p times r. All right, just holding this t steady and dividing p times r over to the left-hand side, but then I like to switcheroo it. You'll get the same answer though. Okay. Let's do another example. And this one, I'm going to let you try on your own. So it says just paid interest charges of $169.05 on a $4,830 invoice that was 2 months overdue. Okay, so notice it's in months. What monthly rate of simple interest was she charged? Okay, so now it's asking for the monthly rate. Okay, and so you can do the reverse of what we did, right? Because R is going to be in years. And so now if you want to convert it to a monthly rate, you'd have to divide it by 12, right? So so a couple of things to keep an eye out for, but I'll give you 2 minutes to work through that, or maybe just a smidge less. Yeah. So first thing we're told, and there's no tricks here, is that I is 169.05. We're also told that the initial invoice, which is the principal amount, right? The initial amount that was due, and then we have to pay interest on that. So now P is 48.30. And it was, so the 169.05 was after 2 months of interest, right? And so here, 2 months overdue. So T equals 2 over 12, right? 2 months out of 12 years, right? I'll write that down. What monthly rate of simple interest was she charged? So now here we want to solve for R as a monthly rate, which means R divided by 12. Okay. So same formula, right? We're just solving for R first and then dividing it by 12. And so let's start out here. I've got I equals PRT. I was 169.05 and P was 48.30 times R, which we want to solve for, times T, which was 2 over 12. I'm going to use that fraction, but of course I'm going to use a calculator, so it doesn't really matter. So then I get R is 169.05 divided by 4830 times 2/12. Just to do that matching calculation or rearrangement, if you prefer it, right, you could have said that, okay, or R is I divided by P times T, right? If you're solving for R and you're multiplying around it, then you can divide to the other side to solve for R, which is what we have here. So let's go back here. So we find that R is, let's see here, 0.21. Okay, but this note that this is per year. Okay, R is per year, right? And that's why T has to be per year or in years, right? And so now we can solve for, so the monthly rate is going to be R divided by 12, which is going to be 0.21 divided by 12, which is 0.0175 or 1.75% monthly. So that's I think the trickiest part about percentages, or sorry, rates, is that we communicate them as percentages, but then we do the calculations with the proportions, right? So the decimal version, but then when we report the answer, we usually report it as a decimal, or as a percentage again, words. Okay, so we've used this formula. We solve for I, we solve for P, we solve for R, we solve for T, right? So we've manipulated this formula as much as we possibly can. So you've seen all the different scenarios now, even though I know it doesn't feel like it, you have, just like that. So I want to show you kind of a cool thing that your calculator does. And I don't know, I think it's really fun to play around with. Let's see where the page break is. Because this is section 4.3. Maybe I'll just start it on a new page here. So section 4.3 is just walking you through how to calculate days between dates on your calculator. So days between dates which we abbreviate DBD, days between dates, on your calculator. Okay. So your calculator has this cool function that it can calculate the days between dates. Why would we care about that? Why would we care about the number of days between dates, right? Because if someone is paying you interest on a loan, right? Well, yeah, then okay, you want to fudge something, but what if you owe money, right? Then you want to start on, let's say, February 3rd, and you want to finish paying interest on February 10th, only the days that you actually borrowed the money for, right? So there, it's relatively easy. You can just count the days between dates, but what if it's over years? Right, then what happens? So this is just an easy way to calculate the days between dates. Okay. So your calculator can calculate the number of days between two dates. The number of days between, and let me see here, date 1, which I'm going to abbreviate DT1, and date 2, which I'm going to abbreviate DT2, and that's to match the calculator. Okay. so how we use it, right, is for more precise interest calculations. Okay. This will allow us to do precise interest calculations. Okay. So to access the DBD calculator, let's see here. To access the days between dates, that looks like a P, but days between dates calculator, the first thing we're going to do, and maybe I have a screenshot. Well, I know I have a screenshot of the calculator here. Maybe this one. No, I don't want one with a value on the screen like this. Okay. So what you're going to do is it's here in the date button. So to get to the date, you have to hit second and then date. So to access that guy, you have to hit second one. Okay. So if we go there, change my screen. So I'm going to go to second date. Okay. Notice that it has date 1. Okay. And it has a specific format for the date. We can scroll down using the arrows. Okay. It'll change to date 2. Can scroll down, and then it has the DBD, the days between dates. Okay. And if I scroll down again, it's the ACT. We're going to ignore that. And so I've got date 1, date 2, and days between dates. Those are the ones that we're going to use. Okay. So here, let me screenshot this. Oh, I bet you it's playing an ad now. That's annoying. Let's see here. Use up and down to scroll between date 1, date 2, and DBD. To scroll between DT1, DT2, and DBD. What we're going to be able to do is we're going to be able to give it 2 inputs, right? And then we tell it to calculate the third, right? So there's 3 slots, right? Date 1, date 2, and days between dates. If we give it any one of those or any 2 of those 3, right, we can ask it to calculate the third. Okay. So given 2 of the 3 inputs, our calculator can solve for the third. Can solve for the third, right? So whether that be, so usually it's the days between dates, but sometimes, right, I take out a loan on June 2nd, 1992, and I borrowed it for 400 days, right? What date did I return the money on? Right, so that kind of thing. But before we can do that, the dates are entered in a very specific format. Okay? So the dates are entered. Oops. In the format month dot day year year. Okay. So this is going to be really important. Very short-sighted to only have 2 for the year. Okay, so this does make a mess sometimes. There's a transition year where it starts talking about 20, I think it's maybe 1944 versus, so 1943 versus, I think it's in the 40s somewhere. And so here, notice with only year instead of year. Not sure why they didn't do that. We might run into issues, right? So we might run into issues with, for example, 1910 versus 2010. Oops, forgot a 0. Right, there's a transition year. Okay, and I think I had a note, because I know I've solved it or I've figured it out in the past. Okay, but let's try it. Okay, so how do you know if it's 1910 or 2010? Oh, sorry guys. Not a fun ad. How do can I close it? Okay. So let's do maybe June 6th. June 6th. So June month 06, 06. And then year 1910. Right. So then 10. Notice how it doesn't save anything yet. So what you have to do is you have to hit enter to save it. And what you'll notice is that the equal sign after date 1 will show up, and that's how you know that it's registered it. So if I hit enter here, then it shows me that, okay, you meant 2010, right? And so, right. And so here, let's see here. I'm gonna save that. So for example, if we enter, let's say June 6th, 1910, right? Or if we try to enter June 6th, 1910, that in the format month dot day year, right, would be 06, 06, 10, right? But then what happens? It becomes 2010 instead. And I'm pretty sure there's a transition, and maybe with the newer models, it might be the 80s. Okay, but it used to be in the 40s sometime, I think like 44. But just make sure that the date is what you want. Of course, I'm not going to try to make you use dates that aren't going to work. Okay, although I accidentally did that on a test one time, it wasn't working. Big mistake. That was my mistake. I won't do that. Okay, so in order to store a value, right, then we hit enter. Okay. So to change DT1 equal to 060610, we must hit enter to save it. Okay. You'll see the equal sign show up after the DT1. Okay. So what you can do, right, is you can fill in the dates that you want, for example, and then we said that as long as you have 2 out of 3, then you can compute the last one. Okay. And so after filling in 2 of the inputs, and of course I have an example, but I just want to show you how it works first. So after filling in 2 of the inputs, go to the input that you, so then you scroll, right, that you want to calculate, and then you hit compute. Go to the input you want to calculate or compute and hit this guy. Compute. CPT. In terms of your work, right, I always find that it's easier if I can just show that this is the one I calculated. Okay, and so to show that there's a value that I've calculated or computed, right, then I use a little star. Okay, so in my work, I use a star or an asterisk to show which value I computed. To show which value I computed. Okay. So let's see an example. It's going to be example 139. Of course. So the next one on our list here. Calculate the amount of interest owed on a loan of $3,800, which was advanced on June 17th, 2005, and repaid on October 1st, 2005, at a rate of interest of 10.75%. Okay, so there's a couple of components, and just like we saw in the previous sections, right, we're going to need to do a little bit of work using the days between dates to find T, right? And so they're kind of derivatives of T, but here we go. So the loan amount, which is P, was 3,800. That's the first piece of information that we want. It actually says to calculate the amount of interest owed. So it starts off telling us what we want to find. So here, I is what we want to find. Now, it was advanced, which means the loan was given on June 17th, 2005, which means DT1 is June 06, date 1705. I usually just start out by converting it to the month, dot, day, year. Okay, and so I'm just going to hop right to that. Okay, and it was repaid on October 1st, 2005, which means that date 2 is October, which is what, 10? The 10th month, 01/05. And the interest rate R is 0.1075. All right. So the first thing I need to do, right, I'm trying to solve for I have P, I have R, and I sort of have T, right? And so I need to solve for T first. And so we need to solve for T. So in order to show how I'm going to do that, how I show it in my work is date 1, I'm just going to jot it down again, is 06.1705. Date 2 is going to be 10.0105. And then days between dates. And notice, so here's where I'm going to show that that's the one I'm calculating. But then when I list it, right, it'll just be part of this list, right? So that's why it's hard when I'm looking back at this, which one did I calculate, right? And so I use this little star. Okay. All right. Now I'm going to try something so wild. How do I do squished? I thought maybe I could. That's okay. Let's try it. Okay, so date 1, kind of close, is going to be, so I'm in the days between dates calculator. How do I get out of the, so if I want to start fresh, if I want to get out of the days between dates calculator, right, I'm in the second menu. So then I have to quit that menu. So you hit second quit. Okay. So, okay, I'm going to go back in to the days between dates calculator. So I need to go second date. And now I'm in the days between dates calculator. So now I want to go adjust date 1 is going to be 06.1705. It's not stored yet. I have to hit enter. Oh, it looks like a 9, but it's 05. I'm confident. It's just that I have them both on the same screen. Okay, so I've entered that. That looks good. So then I'm going to go to date 2 and I'm going to adjust it. And it's going to be 10.0105. Again, it's not going to be stored until I hit enter. Notice that there's no equal sign after date 2. Sorry. I hit enter. Sorry. Just not stopping. There's people in the hall. It makes her so mad. So now date 2 is stored, right? But you had to hit enter. So now I want to compute. Maybe. Let me go talk to this nasty. Here's the bad girl. She's a bad girl. Okay. You gonna quiet down? Okay. So now we need to compute the days between dates. And so I'm going to go down to the days between dates. And this is where I'm going to hit compute. Okay. CPT top left corner, compute. And I think it computed 106. Okay. So there's 106 days between those two dates. Awesome. So I'm going to see if I can write that. It's oh so tiny here. 106. Nice. Days. Okay. So now, how do I? I want to close this side, just the one side though. Or maybe I'll keep it like that. Okay. So then T is going to be 106 over 365. Sorry, guys, just a sec. No. Okay. Now we're ready to solve I equals PRT. And I wish I could remember how to close that. There, I did it. Okay. So now I want to solve for I. We had to do a little bit of work for T, not too bad, right? Just kind of flexing those muscles we just learned. The principal amount was 3,800. The rate was 0.1075 and time was 106 divided by 365. Okay. I then is going to be 118.6328767. But remember that I is a dollar amount, right? So it's a dollar amount. Don't confuse R and I. I is the amount and R is the rate. So the dollar amount is $118.63. Okay. All right. Let's try another one. Let's do 140. So this one, it doesn't have a year. So let's just assume it's this year and hopefully our calculator can handle it. Okay. So here, assume the year is 2023. Okay. On June 26th, or maybe 2022, because then it has already happened. How about that? Because we haven't seen June 26th yet. On June 26th, Laura put $2,750 into a term deposit until September 3rd of 2022. When she needs the money for tuition, books, and other expenses to return to college. For term deposits in the 60 to 89 day range, so that's a clue that our days between dates is somewhere in there. Her credit union pays an interest rate of 4.25%. How much interest will she earn on the term deposit? Okay, so here, let's see here. So the initial amount, P, is $2,750. Okay. And date 1 is going to be September 3rd, 2022. So September is 09 and 03, 22. Yeah. Oh, sorry, that's date 2. Whoopsies. I missed it. June 26th. Date 1 is 06. Maybe stop it. 06, 26, 22. And this is just kind of a clue to change. And 69 sounds reasonable. I'll get there in just a second. Oh my gosh, she's driving me nuts. Like 0425. I'll be right back. Hopefully she'll just go have a nap now. Okay, so let's see here. Okay, so we've got the rate, and then finally we just want to find how much interest will she earn here. So we're looking for I. All right, let's hop to it. Date 1, right? Because we need to figure out the number of days between dates before we can find T. 06, 26, 22. Date 2 is 09, 03, 22. And the days between dates is what I'm calculating, right? So just to highlight that again, I'm going to stop highlighting soon, but right, just to show that that's what I'm finding. And you've already said everything that can make noise is making noise today. Okay, here we go. There. Okay. So I'm already in the days between dates calculator. So all I have to do is I have to just go back and overwrite the dates. That's totally fine. Just don't miss anything, right? Don't leave the old date. And so date 1 is 06.2622. Now I'm going to hit enter just to make sure that it's 2022, which it is, right? I think if you tried to do something like 2080, right, it would probably go back to 1980 instead because it's closer. But well, let's try it. 06.2680, enter, takes us back to 1980 instead of 2080. So just be a little bit careful, but nothing to worry about. 06.2622. That's working. Go back to or down to date 2, 09.0322. Enter. And then calculate the days between dates. It has the old days between dates, but when I hit compute, it'll update with 69. Nice. So 69 days. And so T is 69 over 365. Okay. Now I is equal to PRT. So we are solving for P was 2750 and R was 0.0425. and T was 69 over 365. So to exit the days between dates calculator, right, you go second quit or second compute. So second quit. And then I'll show you how to keep 69 over 365 if you want to store it, right? So then it's going to be 69 divided by 365. You can just keep it on the screen and use it, but just in general, right, you want to keep all those decimal places. So you're going to store, I'm going to store it in 2750 times 0.0425 times recall 1 equals. So the amount of interest, oh, I was looking at the wrong one. I get 22, or I'll do the full value first, 0.941780. So I in money, now I'm gonna close this up because this doesn't look very good. Not that it looks that great. $22.09. Yeah. And so, right, how much interest will she earn on the term deposit? Whoa. Did you guys see that? It looks like the ink is smudged, but it's electronics. So I don't know how that happened. Maybe the zooming in and out. Hopefully that'll clear up. I don't know. Kind of fun, I guess. It's like I took my hand and I smudged it, but it's not real pen, so I'm not sure. All right, so let's see here. All right. How much interest did she earn? $22.09. That was the question. All right. Hey, look at us go. I think we're ready to introduce that next formula that's on the formula sheet. Okay, and so let's see, section 4.4 is on present and future values. Oh, future values. Okay. So in the example, right, so from the previous example, we saw that, right, that Laura invested $2,750 or $2,750, right, for 69 days and earned $22.09 in interest. Okay. We saw Laura invested $2,750 for 69 days and earned $22.09 in interest. Okay. Which means that the future value is what we're going to call it, right? So the future value of $2,750 after 69 days is $2,750 plus $22.09. Okay. Which means the future value, and I'm going to capitalize it here because it's going to be important, which means the future value, just to clarify, the value after 69 days is 2,750 plus 2209, right? Which is, let me erase this here. 277209. Yeah. Now, to visualize this, usually what we do is we use some sort of timeline. Now, the timeline is only meant to help you organize information, but it is going to be so powerful for laying out all the information that you're given. Okay, so as an example, right, how we're going to visualize this is that on June 26th, 2022, Laura invested $2,750. And that stayed there for T equals 69 over 365 years. Until I think it was September 3rd or something like that. Yeah. Until September 3rd, 2022. And now she has 277209. In general, P, right, over time, right, so over some set amount of time, goes into or kind of becomes a future value. So here, FV. Okay. So P becomes this future value. So here we have this present value. And it becomes this future value. And the future value is the principal amount plus the amount of interest. Okay. So the future value is P plus I. Okay. The amount of interest. Now, if we do a little bit of work, so notice that if we take the future value is P plus I, but then we also have a formula for I, so how about we replace it with that? P plus PRT, right? I equals PRT. Now I have a common value of P here. So what I can do is I can write the future value is P times 1 plus RT. Now this is on your formula sheet. And instead of scrolling way up, let's see here. No, I must have had it in here, there. Instead of scrolling way up, just going to copy it from your formula sheet. Oh, that's from last day. So this is where it came from, right? But what's on your formula sheet is this version, okay? But it's because it's just P plus I, which is PRT. Okay? So you can use the I formula if you want, but it's going to be a lot more work eventually. So so now, right, the future value is both the principal amount and the amount of interest, right? So it's the total amount of the loan or the investment, depending on what you're doing. Okay. But like I said, the behavior is the same. So here, the arrow represents time. make a note of that here. All right, so after some time, there's some amount of interest that's accumulated, and that's how we get to our future value. Okay. Just a note on terminology. So the maturity date is the last date of the term. Okay. So here, just note the maturity date oops, I almost wrote date again, is the last date of the term last date of the term of the investment or the loan. Okay, so just like we did before, okay, we're going to use this formula, and we're first going to do an example solving for the future value. Then we're going to do an example where we solve for P, and then we're going to do an example where we solve for R, and then we're going to do an example where we solve for T. And those are all the things that we could possibly do, right? But because of time constraints, we can only do one of each, right? But if I've shown you one of each, then you know how to handle them. Okay, so it doesn't feel like a lot, but it's all that we can do and all that you really need. Okay, so let's see here. Let's do example 141. Copy. Put it on a fresh page here. Oh, and you know what? Maturity value is the future value. Is the future value. There. Okay. I only noticed that because it says calculate the maturity value. Okay. And so really what we want to find, and do I have a color for, let's use this fun blue. Oops. Calculate the maturity value, which means we want to find the future value of a $15,000 investment. So that's your initial investment. Okay. So, oh, I've used pink. The principal amount is 15,000. Okay. At a simple interest rate of 4.75% after 1.5 years. Okay, so the rate is 0.0475, and the time, here they're being nice, is already in years, and so time is 1.5. Okay. We're going to use the future value as P times 1 plus R times T. Now I'm solving for the future value, so that's fine. Can just stay on the left-hand side. P is 15,000 times 1 plus 0.0475 times 1.5. Be really, really careful with your order of operations here, right? You have to multiply these two first and then add it to 1 and then multiply it by 15,000, right? And so I'm going to show that kind of painstakingly step by step, but it's because I need you to do it in this order. In terms of showing your work in the future, you don't need to do it step by step like this, but because we haven't seen a calculation like this in a little while, I'm going to show you how to do it. 0.0475 times 1.5 equals 0.07125. So 0.07125 plus 1 equals, so the future value is 15,000 times 1.07125 times time. Did it take it times 15,000 equals. So I get a future value of 16,068.75, and it's already to 2 decimal places. So that's nice and kind of cooked. So the future value then, so the total amount of the loan that you would owe is $16,068.75. Nice. If you wanted to, you could rearrange this, right? But in this case, the future value is, it's already rearranged for this. And so let's solve for P. Okay, so now let's do example 144. What amount should be invested today in order to receive a maturity value of 17,000 in 8 months if money earns 9% simple interest, and you're allowed to assume that it's per year. If it doesn't say, right, you can assume it's per year. Okay. So here, what amount should be invested today? So P is what? To receive a future value, a maturity value of $17,000 in 8 months. So T is 8 months, so 8 over 12 years. If money earns, so R is 0.099% simple interest. Okay. So the future value is P times 1 plus R times T. I have 17,000, which is the future value, is equal to P, which I'm trying to solve for, times 1 plus 0.09 times 8 divided by 12. Again, order of operations, but I'm going to go ahead and solve for P, which is going to be 17,000 divided by 1.06. So P is going to be 16,037.73585. In money, I would need to invest $16,037.74. Okay. If you wanted to, so that's the answer, that's good. If you wanted to, you could start here and you can rearrange the variables, right, to solve for P and then plug stuff in. That's fine too. So, or P is going to be the future value divided by 1 plus R times T, right? But that is what we have here. Okay. Good. Let's see here. Okay. So that was solving for P. Let's see here. So I have an example, but it's not an example where we solve for R or solve for T. So I just want to derive those formulas before we move on, because they're a little bit different. Okay, they're not something that we're going to focus on, so that's why I don't have examples for them. But we could also rearrange FV equals P times 1 plus R times T to solve for R and T. So FV equals P times 1 plus R times T. FV divided by P equals 1 plus R times T. So FV divided by P minus 1 is R times T. And the FV over P minus 1 is all minus 1. And then to solve for R or T, right, the next move determines, and that's the only difference here. So solving for R is going to be FV over P minus 1 divided by T, or T is going to be FV over P minus 1 divided by R. Okay. Because these are a little bit more complicated, right? You want to be really careful when you're working through these. And I would also encourage you to just start from these formulas. Okay. And so here, since solving for R and T is a bit more complicated, than FV or P, I would recommend starting from, or even having these formulas, adding these to your formula sheet, right? Is a bit more complicated than FV or P. I would recommend 2 C's. Recommend. I'll change it for a word I know how to spell. I would suggest starting with the derived formulas. Right? So R is FV over P, all minus 1 divided by T, and T is the same, but FV over P minus 1 divided by R. Okay. We can make these problems a little bit more complicated. Now I'm going to stick with the future value, right? So solving for R and T is more of an assignment problem. It's not something that I'm going to get you to do on a test. Okay, so it's more of an assignment. I promise. Okay, but what I want to do is just show you a slightly more complicated problem that we can solve using what we've learned so far. Okay. Let's see here. So this last example is a little bit more complicated, but we have the tools, okay? And so here you're going to see how using that timeline, so drawing out the problem, is going to be really, really helpful. Okay, so kind of a cute problem. So Okie Dokie Finance Company advanced 3 loans to D. Okay, so 3 separate loans. $2,200 on June 3rd, or sorry, 23rd, $1,800 on August 5th, and $1,300 on October 31st. Simple interest at 7.25% was charged on all 3 loans. So they all have the same interest rate. That's not always the case. Okay, and all were paid on December 31st when bonds that she owned mature. So she came into some money and then she paid these off. Okay. What total amount was required to pay off the loan? Okay. And so we're going to assume that the year is 2022 again. Okay. So let's assume the year is 2022. Doesn't really matter, but just don't pick a leap year, I guess. Or maybe it was, who knows, but I'm assuming it was. Was 2022 a leap year? Maybe, can't remember. That's okay. All right, so let's see here. First thing I want to do is just have a number line and just map out the dates. So first thing we're going to do is just map out all the dates that were mentioned. Now it's kind of tricky in the beginning when you're first starting out to map out these dates, okay? But I see June 23rd. Oops, June 23rd. August 5th. Now, what I'm going to mention here is this is just to visualize the problem. So you don't need to spend a lot of time making sure that they're evenly spaced or anything like that, or proportionately spaced. That's okay. But I'm going to put October 31st. I like to have them just evenly spaced if I can. And then finally, so here are the 3 loans, and they were all paid off on December 31st. Okay, now what we're going to do is just write the loan amounts underneath each date. So the loan amount on June 23rd was $2,200. The loan amount on August 5th was $1,800. And then on October 31st, it was $1,300. Now, in order for this to not get too messy, what I'm going to do, and these are just tricks that I've learned over time, right? Doing a lot of these problems. But what I want to do is I want to figure out what's the value of all of these loans, right? After she's paid interest on each of them individually, right? What is the value, the total value on December 31st? So what we're going to look at is we're going to take 1,300 and find the future value on December 31st, okay? And then we're going to find the future value of 1,800 on December 31st, the future value of 2,200 on December 31st, okay? But in order to not make a mess, I'm going to draw these arrows starting from the closest date. It doesn't really matter, but I'm just kind of showing you what I've learned with time. So that 1,300 is going to become some future value, and I'm going to denote it future value 1 because, or 3 if you prefer, right? It doesn't actually matter. But it was the 3rd loan, so future value 3 would also make sense. Future value 2, and then future value 3. When I add these all up, that's when I'm going to have what total amount was required to pay off the loan. Okay. And so here, this is going to become the total amount required to pay off the loan. Okay. So remember, you're just using the timelines to visualize the problem, lay out all the information that you have. Now I'm going to let you work on this, and we're going to use this as a review on Wednesday, my days. Okay, so I want you to try it, and just remember to use the days between dates calculator and try to figure out those future values and try to answer the question. All right, so I'll let you try that. And like I said, we'll use it for review. We'll pick it up on Wednesday. If you have any questions, let me know. But otherwise, I will see you on Wednesday. Stop this recording.